Metabolism encompasses all the processes and pathways needed for cell survival. These processes can be classified as catabolic processes or anabolic processes. Catabolic processes involve the breakdown of dietary components with the purpose of producing energy, most likely NADH and FADH2, which are eventually converted to ATP, a more readily usable form of energy. Anabolic processes will use the ATP produced from catabolism to synthesize cellular components like proteins, carbohydrates, lipids, membranes, nucleotides, nucleic acids, and other macromolecules, as well as maintain other cellular processes. In the well-fed state, elevated glucose in the bloodstream will trigger the release of insulin from the pancreas. Insulin will specifically increase the uptake of glucose by muscle and adipose tissue. In the liver and muscle, insulin will activate glycogen synthesis and glycolysis while inhibiting glycogenolysis. In adipose tissue, insulin will increase triacylglycerol synthesis and inhibits lipolysis by inhibiting hormone-sensitive lipase. The brain will use the ample supply of glucose from the bloodstream, oxidizing it all the way to CO2 and producing 38 ATPs in the process. During fasting, a drop in blood glucose will trigger the release of glucagon from the pancreas. Through the hypothalamus, the brain will direct the production of cortisol, epinephrine, and norepinephrine by adrenal glands. In the liver, glucagon and epinephrine will stimulate glycogenolysis and gluconeogenesis and resupply the blood with glucose, as well as ketone bodies. The liver and muscle will switch to using fatty acids provided by lipolysis of triacylglycerol in adipose tissue. The brain can only use glucose and ketone bodies, but not fatty acids for its energy needs.